I'm here at the Engineering Design Show, and I'm pleased to be joined by Ben Ryan, who is the founder of Ambionics, correct? Ambionics, that's the one. Fantastic. So tell us a little bit about what the company is, what it is you do.
Sure. So I started the company as a non-profit to be able to work with universities, playing around with my ideas about early intervention. So when my son was born, he had a forceps injury, which meant he lost his arm. The NHS said that we were going to wait until he was about 18 months old before they try a prosthesis. My background in psychology, and especially knowledge of neural development in babies, meant that I wanted to challenge that. I thought it was important to go in earlier. And the reason being is I wanted him to be able to accept a prosthesis for a number of health reasons that were downstream. So the company really starts off with babies, but the benefits come when Sol will hopefully be my age, and he'll have a reduced chance of having arthritis, curved spine, and so on. So the occupational therapy side of it is as important as the technology. Yeah.
Fantastic. And what have been your major challenges so far when it comes to sort of the design? Because obviously you're not an engineer yourself, are you?
No. So I think like I said, the most important thing, the problem I tried to solve originally was to make sure that he accepted a prosthesis. So the stuff I did earlier was really easy to make. It's just a piece of cotton wool, a foam arm, and some bandage to keep it on. But I was very lucky. We did a crowdfund to try and raise money in 2017 for my ideas on making a hydraulic prosthesis, so a squishy ball of water that goes under the arm to operate a very basic grab. And that kind of went viral, so we had loads of help. So Autodesk, who are opposite us over there, they got in touch with me and put me in touch with a product designer called Paul Sohi, and he taught me the workflow that I use for designing the sockets. Yep. And the rest of it came like a 3-year-old throws mud at a wall. Eventually some of the ideas stuck. I made a lot of mistakes. Before I knew it, I was designing medical devices. Yeah.
So what are you looking to do now? Because I understand you're trying to get to OT world, so tell us a little bit about that.
Well, so through LinkedIn, I'm looking to try and get support and advice on how to make the best devices for Sol. I've garnered up a lot of support among the clinical community, and we have clinicians now in Pakistan and Germany and the United States. We're really keen to help us get this to other kids as well. It's great what I've done for Sol, but this could potentially be groundbreaking for loads of other kids, but there's a lot of red tape to get through. So our first step is to get our ideas out there, and we've been invited to attend OT World, which is in Leipzig in Germany. It's the world's most important prosthetics conference, and next year is the first time that they're ever concentrating on kids' devices. Yeah. So we really need to be there. We've won a place in the startup area. Sadly, we don't qualify for a trade bursary from the British government because we don't have a year of accounts to show that it's worth backing us. Yeah. We're a non-profit, which was so we could work with universities, but that means we can't take investment. So we're crowdfunding, and I'm delighted to say that we've almost raised the £3,200 that we need to get me and Sol on a plane and spend 4 days in Leipzig next year. More importantly, though, as I've submitted a scientific abstract covering my ideas on I was talking about the brain development. I want to be able to pitch my ideas to clinicians in OT World Congress. So I find out in December whether my abstract's been accepted, but that could then change policy. Yeah. That'll be really cool.
Yeah, fantastic. So if people want to donate to your crowdfunding, how do they do that?
Okay, so you can find us through most of our socials. If you type in Ambionics UK, you'll see all of our crowdfunding stuff, but the actual platform is GiveSendGo/Ben and Sol. Please give generously, thank you.
Excellent. And what about the Engineering Design Show? How's it been for you? You had some good conversations?
Oh, it's been absolutely awe-inspiring. So I always meet students, and they always come with a fresh perspective, and they will always give me insights and suggestions for things that I might want to do next. So that's always great. We've made some great connections as well with companies in the UK, but just the general support we've had from EDS, they donated the space to us. Yep. So this wouldn't have been possible. There's no way we could have afforded the £5,000 or £6,000 it would cost for this. And it's just been a tremendous event, so we're hoping to come again next year.
Fantastic. And tell us a little bit about the ones you've got on display here. You've got some new patterns coming in, haven't you?
Yeah, so we wanted to showcase, really, this is come from our partners, manufacturing partners in the United States, so Advanced 3D. So this is printed in nylon, so it's lightweight and very, very durable, but as you can see, we've got these fetching colours as well. So this nylon pattern is printed through the entire part, and it uses a 3D printer that costs about £500,000, so I wouldn't be able to buy one of those. But Advanced 3D has many of these, and they also have 3 board-certified prosthetists. So between the clinical input that we're getting and also the research that we're doing with Bangor University, we're hopefully going to inform the design changes. So maybe next year we might be actually medically stamping something that's been really, really honed to a perfect geometry using data. So data-driven design, I think, is a really key aspect.
Fantastic. And tell us a bit more about the design. Why does it look like this as opposed to the others you see that actually look like a hand?
Yeah, okay. So, for example, if you look at the main British company that makes children's prosthetics with a multi-articulated hand, it weighs the same as a bag of sugar. Yeah. So you're looking at a kilogram of dead weight on the arm. For children with a longer forearm, that might be okay, but for someone like Sol, it would just be a dead weight hanging by his side.
Yeah.
Runs on a battery. This thing is body powered, so it never runs out of battery. You can wear this in the rain, you can wear it in the mud, you can jump in the sea with it, you can do all sorts of things and not have to worry. The whole thing comes apart and you can clean it yourself. In terms of actually operating it, it operates about 10 times faster than a myoelectric. So a myoelectric, even the world's best, is about a second to open and a second to close. Yeah. So our partners in universities say that's just too slow. You want something you're going to use, it's going to be as quick as your hand. So this opens in the blink of an eye, and there's no limit to the amount of grip force. The amount you can push into it is the amount that you squeeze, so there's no restriction from a motor or anything like that. So generally speaking, using the body power, you're also getting the feedback through the harness. So my son could pick up an egg, and he senses exactly how much pressure he's putting on it rather than guessing. Don't need any fancy sensors or AI. You've already got the wetware in your body, so use the nerve system that's already there. It's way smarter than any circuitry, and get that feedback going to the brain and develop the motions naturally.
Fantastic. Well, yeah, wish you and Sol the best of luck. So have you got anything to say, young man? How's the show been for you?
Really good.
Yeah?
Yeah.
Love it.
Can you do your rap again for us?
My name is Sol and I've got one arm. What I lack in limbs I make up in charm. And now without any hesitation, I play it to my dad for the presentation.
Ooh, drop the
Well
mic.
done.
8 Mile and beyond.
Thank you very much, both. Thank you.
Cheers.